This beast here is a Dukane public address amplifier. It is a variant of model 1U460 or 1U460A. Subtle difference. This is actually a 1U460C, and really the only difference between these, it has to do with mounting. This particular one came with a rack mount assembly rather than a cabinet that covers the whole thing. Electrically, they're pretty much identical and work very well. I collect this particular model for reasons I'll get into later. This one, as you can maybe able to see, I hope, kind of got some cobwebby stuff on it, spiders and dust and smoke and whatever. The reason it's here is not a restore or repair, it's just a maintenance. It's well in need of it. It's nothing else, just to blow the dirt off of it, out of it. But I do want to go over some of the things about this particular model amp. It's going to take more than one short vid to do that. There's quite a bit to go through. I'll go over some of what I do. I'll act as if, or behave as if I've just got this on my bench, fresh, and don't know anything about it. Of course, I do know about this amp. I have been using it, not very recently, but I do use it periodically as a test bed for tubes, other things, experimental stuff. I use it as a practice amp for guitar, which these make really wonderful guitar amps without changing anything, except maybe a couple of tubes that might be less than efficient. What I've got in it now, tubes-wise, is junk. Well, they work, but there's nothing special about any of them, except for maybe one. 5U4 rectifier. The one that's in here, I don't know its condition. I often plug nearly dead ones in and play through the amp, my guitar or other things, just to see what happens. What happens to the sound. How does it sound when the power supply collapses? And that's been a bit interesting. The output tubes are 5881. Another variant of that is 6L6GC, interchangeable. You can put them. I put regular old 6L6s in these beasts, and they work just fine. This being a public address amplifier, it's meant to be on all of the time. It's not like a guitar amp, but it works wonderfully as a guitar amp, which again we'll get into. But it's meant to be on, turned on, even if it's not. There's no signal passing through it. It's very ruggedly designed so that it can be on 24/7, 365, and not have troubles or overheat or smoke or anything. So these things of amplifiers I've seen, these things are tanks. You have to do some serious damage to blow one of these things up. Given the tube lineup, the iron that they have in them, meaning these transformers, which are massive, and other things about it. And again, we'll get into those details at some length later on, I'm sure. So, first order of business is to clean the thing, or pull all the tubes, get all this dust off of it. I think that's probably really only problem with it. It's just a little dirty. I have 15 of these. As I said, I collect this model, or those similar to it, and for good reason, I think. This particular one, the reason it's being used as it is because it's the one that I have that has had the most work done on it by someone other than myself. Namely, these three electrolytics are replacements. They are proper replacements, actually, and kudos to the technician that did that work. Did it right. Very well done, in my estimation. These capacitors, these three multi-section capacitors, are all sections rated at 500 volts. Well, normally you get these things are rated 450 or so. Can't do that with this beast. The B plus on this guy runs about 480 volts, so 450 volt electrolytics, not a good idea. And maybe in a couple of places where the voltages are lower. But as this thing was meant to run constantly, not like a guitar amp, which was intermittent at best, everything is overkill. The size of the transformer, so look at the size of this power transformer. This thing, they rate this at 30 amps. Oh, I'm sorry, 30 watts of RMS continuous output. 30 watts. This can do way more than that. It 50 watts and still get reasonable distortion figures out of it. But because this was meant to run continuously, even if it's just idling and no signal through it, would not overheat. And they don't. Trust me on that. I run these things a little hot and no troubles at all with them. Interesting, they put a couple of high dissipation resistors. That's what these are. I think one's a 2K, one's a 10K. Those are in the power supply circuit, but they put them above the chassis. That avoids a whole lot of heat within the chassis, where all the capacitors and resistors are. You don't need a whole lot of extra heat down there. We took the extra expense to buy these top-mounted chassis, top-mounted resistors. Kudos. And that's exactly what you want to do if you want the thing to last forever. Oh, this thing has, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 tubes in it. Let's see, 1, 2, 3, 4, 5, 6 of them are dual or twin triodes. So, multiply each one of these guys by 2 and you get an idea how many stages this thing has. Of course, 5U4 rectifier, a couple of 6L6 GC or 5881 output tubes, push-pull, of course, class AB1. Phase inverter also drives these guys. Another stage, this is a 12AU7. This also is a 12AU7. I'd have to look again. It's close at hand, but for now we're not worried about it. But there's tone amplifiers. This thing has bass and treble controls, and 2 triode stages of amplification up front, which may also be associated with the tone stack in this thing. It has mic 1, mic 2, mic 3. So that's 3 microphone inputs. That's these guys, which each have 2 stages of amplification, twin triodes, each one of these. Now, the some of these tubes are out because I wasn't using any more than one stage, so these are just empty sockets. I was using it, as I said, as a guitar practice amp and other things, so there is one 12AX7 plugged in back here. It has sockets here, these octal sockets, which right now have these shorting plugs in there. Those are actually factory, depending on how you ordered it. More into that later, but for a high impedance input, a high impedance microphone or a guitar or something like that, you wouldn't use microphone transformers that convert the microphone inputs to lower impedance. 300 ohms or 600 ohms, something like that. More into that later. So that's the plan. The first thing is I'm going to pull the tubes all out of it, suck the dust away with a vacuum cleaner, wipe it down on top, and show a little bit more about the top end of it, at least from this perspective, and of course show underneath. I know if some of you folks are anything like me, you're like, hurry up and turn that thing over so I can have a look underneath. Well, we'll get there. But for now, I'm not going to bore anyone with the cleaning process. Pretty much know how that goes. Vacuum it off, pull the tubes, vacuum it off. Maybe a little bit of Windex here and there, a little bit of smoke stuff. Lots of spider webs. A lot of spiders here for some reason. Spiders, but what we don't have are other insects. So that's the plan. And well, see it.